Tuesday, Thursday, Saturday, we have this PYQ series. So stay tuned every Tuesday, Thursday, Saturday, 4 p.m. NSEP PYQ series. Now, my name is Bhavdeep, and I'll be encouraging you, as always, to go out, look in nature, explore nature. Physics is all around you. That's how you learn physics. I will not be doing any spoon feeding here, as always. I will clear your concept. I'll encourage you to finish the steps yourself. This is not a spoon feeding like solutions given for each question. No, that's not happening here. This is more like a conceptual class. Exam is on 24th of November. I'm sure you have filled out the form. So let's start with the very first question. Very good question. I like this question. A cyclic process. So you start from 1, 2, 3, 4, 5, or not 1, 2, 3, 4, 5, rather 1, 2, 3, 4, and then back to 1, consisting of two isobars. So this is isobaric process where the pressure does not change. One isochoric, 1 to 2, and 3, 4 is a straight line, but note they are saying 3, 4 lie on the same isotherm. So this is isothermal process where temperature 3 and temperature 4 are equal. So remember, volume 1 and volume 2 are same. Pressure 2, 3 are same. Pressure 1, pressure 4 are same. So are temperature 3 and temperature 4. There's a work done. I mean, work done is an easy piece of cake thingy that you have to find the area enclosed in the cycle. But what makes this question interesting is you have to find it in terms of temperatures only. Let's start it. I mean, it is basically just a trapezium. Trapezium area is half times the sum of the non-parallels or the sum of the parallel sides multiplied by the distance between them. So the average of these two sides multiplied by this. So let's get started. The work done is half times this. So this is volume 4 minus volume 1. So volume 4 minus volume 1 plus volume 3 minus volume 2 plus volume 3 minus volume 2. I mean, let's start reducing the variables. Why do I want to write volume 2? Volume 1, volume 2 are same. So let me write volume 1. So that's the average of these two multiplied by this. This is P2 minus P1. So P2 minus P1. And you will start seeing the answer right away. T2 minus T1, T2 minus T1, T3 minus T2. So I can clearly see it is either, I mean, B is not an option. I can clearly see that. I mean, I start eliminating some choices out there. Okay. Now this P2 minus P1, somehow we have to convert it into T1. So I know I need some pressure times volume over there. Right. So start visualizing what will you do. You need some volumes to be multiplied so then you can use PV is equal to nRT because there's nR there and T there. Another thing that I notice here is I need minus 2 there. So I have minus 2V1. Right. So if I simplify this, let's do that. So V4 plus V3 minus 2V1. So V4 plus V3, I'll use the same color here so that not to confuse you, plus V3 minus 2V1. We have minus 2. I have to get rid of V1. I can take advantage of that. I can take this V1 out and then multiply here. So I get two things. One of them is I can remove V1 here so that I get 2. So if I remove V1 here and multiply there, I can get something in terms of temperature. So let's do that. So basically what I'm saying is divide this whole thing by V1, multiply this by V1. So what you get is 1 by 2. I need 1 by 2. And then I'm getting V4 by V1 minus V3, oh sorry, plus V3 by V1 minus 2. I have achieved something here. I need 2, okay? And then times P2 V1, P2 V1 minus P1 V1. Okay, this looks like nRT1 and I need temperature there, but this is combination of P2 V1. What's going on? Then you realize volumes are same. So you do one step at a time, these volumes are same. So you can write this as, instead of V1, you write it as V2 because now you're one step closer. This is nRT2, nRT1. So I'm getting T2 minus T1. Wow. So we have so far achieved 1 by 2 nRT2 minus T1. This is all that. But what about this? Right, so we know these two are taken care of, but is it this one or this one? Let's see. V4 by V1. So what one is this closer to? There is V1 here. So remember, this pressure is constant here. So we are saying V4 by V1. V4 by V1 is definitely T4 by T1. It's a constant pressure. PV is equal to nRT. The ratio of volumes is same as ratio of temperature. So I can write this as T4 by T1. This is T4 by T1. V3 by V1. V3 by V1. It's not getting me anything, but yeah. So but then I realize V3 by V1, V3 by V1 can be written as V3 by V2 because it's a constant process, pressure process. So that can be T3 by T2. So that can be T3 by T2 plus T3 by T2 minus 2. So you have all this. Now this is T4 by T1. I mean, I have got everything. See, look at this. This is nRT2 minus nRT1. So this is 1 by 2 nR. Then I have T2 minus T1. Now look at this. In the third option, everything is matching. Half NR, T2 minus T1, T2 minus T1, negative 2, T3 by T2, T3 by T2, T3 by T1. Oh, this is T4 by T1. But wait, this is isothermal. So these temperatures are equal. You can just remove this and this one is same as T3. Now, what we learned from this question is basically you have to look at the options and start getting closer to them one step at a time. Because if this were a board exam question, you might have given a different combinations of those temperatures and volumes. But when you have to choose these, one of these, you have to get which one matches here. It is definitely not zero. I mean, I should have eliminated this one also. It's not zero. Okay. Beautiful question, but easy question. An insect of negligible mass, that's the insect, is sitting on a block of mass m tied with a spring of force constant k. The block performs simple harmonic motions vertically with amplitude a in front of a mirror which is inclined at 60 degrees with the vertical. The maximum speed of the insect relative to its image will be. First of all, we know one thing for sure, very basic elementary thing. So let's say there is a person here moving with 5 meters per second. The image will also be moving with 5 meter per second. So how fast is the person moving with respect to the image? 10 meters per second. If the person moves with v, this moves with v, the total overall is 2v. But now let's change the situation. Right. Okay. So we know that. Okay. Now let's say the person is moving with velocity v here. This is also moving with v here. So it's not contributing to any, so they're just together, close together. So relative to this, there is zero velocity. So if the person was moving with 5 meter per second, moving with 5 meter per second, what is the velocity of the person with respect to image? Zero. They are both moving with the same velocity in the same direction. So there is no relative motion with respect to each other. But if they move in this direction, there is double the velocity. If they move inclined, so let's do another scenario here. So let's say this person is moving with v at an angle of theta. I would say v cos theta, v cos theta. So 2v cos theta is the relative velocity because v sin theta does not contribute anything over there. So with that concept out there, let's first try to understand how fast is this oscillating. See, mass of m, amplitude of a. So when you pulled it down to a, you gave it a potential energy of half ka square. This is a very easy question. You gave it a potential energy of half ka square. And then when you release it at the center point, it will have converted all its potential energy into kinetic energy, which is half mv square. So this mass doesn't cancel, nothing cancels, actually half cancels here. So the velocity is equal to root of k by m times of a. So that's the maximum velocity with which that insect would ever be moving in this direction. But they're saying what is the maximum speed of insect relative to its image? Now if I were to draw this here, the insect is moving with this velocity here. And they're saying this angle is 60 degrees. So wouldn't this velocity, so this is the mirror, so that velocity cos component doesn't contribute to any motion because its image is here. So when the insect's velocity, this component doesn't contribute any relative motion with respect to the image. This one contributes. So what is this velocity? This velocity is sine 60 of this value. So what is that value? That is square root of k by m times a times root 3 by 2. That sine 60 is root 3 by 2. So that's the velocity with which it is moving up. But the same velocity the image is moving down. So what is the relative velocity? This is the value root 3 times of that. That is your answer. I mean, I would say they should have made this question a little more challenging by giving this root 3 by 2 as an option there. Because many students would have made a mistake. Oh, there's my answer. I will take the component, but then you got to double that also. Great. A concave lens, let's start writing because when there is so much of data, sometimes it gets confusing. A concave lens of focal length 10 centimeters, so this is 10 centimeter focal length, is placed between two convex lenses of focal length 10 centimeter. Okay, this one is also 10. Okay, this one is negative 10 and this one is positive 10. Okay, and 20 centimeters. So this one is positive 20. At a separation of 5 centimeter between, so this one, the distance here is 5. Okay, and that one is 10. Okay, perfect. We know the situation. Another saying, an object is placed at 30 centimeter here. So let's say this is the object and this is at 30 centimeter mark. The final image is formed beyond the third lens at a distance of v from it. So the final image is formed somewhere there and we got to find where that is. Let's do very easy. 1 by f is equal to 1 by v minus 1 by u. So this object for this lens, let's see where does it form the image. So 1 by f, so that is 1 by 10. I'll use white color here. No, so 1 by 10, so that's 1 by 10 is equal to 1 by v, I don't know, minus 1 by u. Minus 1 by u. But u itself is negative 30. So minus minus becomes plus. So plus 1 by 30. You bring that here. So 1 by 10 minus 1 by 30 is equal to 1 by v. So v comes out to be 15 centimeter. So this lens takes this object, creates an image 15 centimeters there. So it creates 15 centimeters. So this is 5, this is 10. So this lens makes an image right here. Right, so I'll use blue color for that, maybe. Yeah. So this image, the image of this is formed there because 15 centimeters is right there. But the point is now this lens takes this as the object and it applies its own equation. So it says 1 by f. So 1 by f is negative 1 by 10. I don't know if that is legible to you, this color. Let me double check. Yeah, it's legible, it's clear. Yeah. So this has a focal length of 10, but negative 1 by minus 10 is equal to 1 by v. I don't know how much is v. Minus 1 by u. 1 by u, but how much is u? So the object for this is here, which is 10 centimeters from here, and that's positive. See, u is negative, yeah, but that's when it is on the left hand side. Now this is a virtual object which is on the right hand side. So that is a positive 10. So minus sign is part of the formula, 10 is positive. So these two cross out. So what I'm getting is 1 by v is equal to is 0. 1 by v is 0. Or v is infinity. So this forms the rays which are parallel. And if the rays are parallel going into that, this will say, okay, I'm going to focus them at the focal point, which is 20 centimeter. So your answer is, it is going to form an image 20 centimeters from itself. This is your answer. Very, very easy. I don't know, man. I mean, these kind of questions, they take time. I mean, they're not difficult, they take time. Good quality question here. A point source of light is placed at a depth d below the surface of water in a large, deep lake. Fraction of light that escapes in the space above directly from the water is given by. See, how do we start? This light source would be giving light here in all the directions. But what light escapes? Not all light would escape because some light would reflect back. Total internal reflection. That would happen here. So what light can escape is if it is within the critical angle. So if this were the critical angle, so then this light goes here and everything, so these critical angle, this light, anything here can escape. But then if you realize the situation is more like you have a sphere here. I'm not very good with drawing spheres. I'll try my best here. Yeah, much better. So basically the light is going in all directions. Only this part of the area, right? So if you have a sphere, let's go to some math class here. If this is your sphere and you say my angle is let's take the center point there. So let's say this angle is theta. Then how much is this area? This area is half times 1 minus cos of theta. This fraction of the whole thing. I mean, you can do that. You try to integrate. It's very easy. We might have done earlier. So this portion of 4 by 4 pi r square, this is the fraction of light that will escape out. Okay, but then how much is theta? We know definitely sine of theta in this case is going to be 1 by mu, right? That critical angle, sine of critical angle is 1 by mu. Nothing to memorize. It's all coming from Snell's law. Sine theta is this. I want to find cos theta. So once 1 is equal to sine square theta plus cos square theta, that gives me cos theta will be square root of 1 minus 1 by mu square. So I can clearly see this is my answer. So 1 by 2, 1 minus cos theta. So this portion of light is going to escape out. This is more like a math question rather than a physics question. But these kind of questions, there is a chance of making mistakes. And that's why I always encourage, while you save few seconds with these questions, don't spend too much of time, but at the same time, be careful not to make any silly mistakes. Because if you lose marks with these easy questions, you will regret a lot later, right? So if this was easy and logical, like, share, and subscribe. Tell your friends about it. Tuesday, Thursday, Saturday, every week, I'll be here with PYQs. Now, if you want to subscribe to a paid course, we have started for NSEP 2025 course, JEE 2026, and we are targeting long term here. But if you want to target a course for 2024 upcoming NSEP, we have the course for that also. You can see the link below. So you can enroll for this, and for the next 2.5 months, you can prepare with the chapters we are studying here, give the test with the full Josh, and then next year give it 100 times the Josh. Another option is you can enroll for 2024 ka course. We have recordings also available, and so see you soon. And then these are the modules here. We have spoken a lot about it. Like the prerequisites are your Josh, your energy is the prerequisite here. You can use BS Pro 1 coupon code, or you can click on the link below. They will apply the coupon code automatically. So many students have been getting gold medals, silver medals, bronze medals, and I would love to see your pictures over there. So keep up the high Josh, my dear students. I will see you very, very soon. Bye bye. Take care.